All right, we have learned how to draw the Lewis structures of ionic compounds in chapter 4. We have also just learned the steps of drawing Lewis structures for covalent compounds. But there's one unique category of compounds that we kind of left it out, and that is the ionic compounds containing polyatomic ions. Among all the Lewis structures we drew so far, none of them belong to this category. Why? Because inside the ionic compounds containing polyatomic ions, there are both ionic and covalent bonds. The covalent bonds are the bonds that linked all the atoms within the polyatomic ions together. The atoms within the polyatomic ion are joined together through covalent bonds. And the ionic bonding is the bond between the oppositely charged ions. Again, in the ionic compounds with polyatomic ions, there are both ionic and covalent bonding. Before we draw the Lewis structures of these kind of compounds, let's answer this question first. In which of the following compounds are there both ionic and covalent bonds? All right, we know that. We need to pick the ionic compound that contains polyatomic ions. That will be our answer. Methane, nonmetal, this is covalent. Sulfur trioxide, nonmetal, this is covalent. So magnesium chloride, okay, metal, nonmetal, ionic. There's a covalent bond here, covalent bond only, ionic only. Ammonium chloride. Ammonium is a polyatomic ion. Chloride is negatively charged. So between ammonium ion and chloride ion, it is ionic bond. Within the ammonium ion, the 1 nitrogen and 4 hydrogen atoms are connected by covalent bonding. So this is the answer. Ammonium chloride. Inside ammonium chloride, there are both ionic and covalent bonds. Now let's try to draw the Lewis structures for these two compounds. One is ammonium chloride. One is sodium carbonate. First of all, they're ionic, so their Lewis structure should look like ionic compounds. Remember how the Lewis structures of ionic compounds look like? Symbols, electron dots in brackets, charges outside the brackets. All right, so inside ammonium chloride, there's an ammonium ion, there's a chloride ion. Overall, the structure should look like this. The negative ion is chloride, so nonmetal, always 8 electron dots. All we need to do is to figure out what is here. Inside here should be NH4. Whatever Lewis structure is for NH4 plus should be placed in this space. Make sense? All right, we'll come back to work on this one later. Let's lay the overall Lewis structure out for sodium carbonate. There are 2 sodium ions. So if there are 2, we put them one below another. It is a metal. Do not put any electron dots around it. Charge outside. Carbonate carries a 2 negative charge. Here we need to figure out how to write CO3 2 negative Lewis structure and place it here. Make sense? All right, let's come back to work on the Lewis structure of NH4+. Once we figure it out, we'll place it in the blank space for the positive ion in this case. Well, since the nitrogen atom and the 4 hydrogen atoms are connected together through a covalent bond, we have to follow the procedures we just learned to write the Lewis structure of ammonium ion. So step number 1, total number of valence electrons. Nitrogen 5, hydrogen 1, there are 4 hydrogen. That's 4 plus 5 is 9. However, the total number of valence electrons will not be 9 because the whole thing carries a positive charge. That means it is missing 1 electron. So altogether, there are 8 valence electrons. Step number 2, lay them out, choose the center atom, and connect them with a single bond. Nitrogen in the center, 4 hydrogen outside, connect them with a single bond. Give outside atoms, number 3, outside atoms 8 electrons. In the case of hydrogen, it is 2. All hydrogens around right now, each one of them has 2, all set. Nothing to do for step number 3. Number 4, give remaining electrons to the center atom nitrogen. How many are remaining? We have 8 at the beginning. We used 8 already. Nothing remaining. There's nothing we can do. Number 5, check to see if the center is happy. Look at the center atom, nitrogen. It has 8. It is happy. We're done. So this is the Lewis structure of ammonium ion. We're going to put this one here. This will be the Lewis structure of ammonium chloride. Let me rewrite it out. This will be the Lewis structure of ammonium chloride. Let's work on the second one. We still need to do the Lewis structure of carbonate. Once we're done, we'll place it in the bracket. Then we finished the Lewis structure of sodium carbonate. Follow the steps. Step number 1, total number of valence electrons. We have 3 oxygen, each one 6, 3, 6, 18. Carbon 4, 22. 22, the whole thing carries 2 negative charges. That means 2 extra electrons. So we have 24 valence electrons. Step number 2, choose the center atom, connect them with a single bond. Carbon in the center. That's step number 2. Step number 3, satisfy the outside atoms with 8 electrons. Step number 4, give any remaining electrons to the center atom. Let's again check how many are remaining. We have 24 at the beginning. Now 8, 24, nothing remaining. Don't give carbon anything. Number 5, check it to see if the center atom is happy. Center atom is carbon. Carbon needs 8. Right now it has 6. Carbon is not happy. If it's not happy, what do? Take a lone pair from an outside atom and start sharing it with the center atom. There are 3 oxygens. Which one you choose? The same thing, doesn't matter. So just choose 1 oxygen. I'm going to take a lone pair from this oxygen off, put it in the center to form a double bond. Now carbon is happy. That's the Lewis structure of carbonate. I'm going to put it here. All right, this whole thing is the Lewis structure of sodium carbonate. practice, draw the Lewis structure of potassium sulfate K2SO4. Pause the video, follow the steps that we just went over. Try to draw the Lewis structures of potassium sulfate. Once you're done, come back to check the answer. This is the Lewis structure of potassium sulfate. That's what it is. So within polyatomic ion, all covalent bonds between the ions, ionic bonds, we have positive and negative. This is ionic. Inside the polyatomic ion, covalent. Do not write the Lewis structure like that. You are not going to share electrons between potassium and oxygen. That's a metal, not metal. Metals are loser. They will become ions. So do not write Lewis structures for any compounds with polyatomic ions by writing all the electron sharing. Okay. There must be ions. Polyatomic ion charge is not localized on a particular atom. Okay, so sulfate, the charge is not on sulfur or a specific oxygen. It is associated with the ion as a whole part. That's why the charge is placed at the outside of the bracket. See you next time.